of people. Okay, so markings, as we've seen, are just something we put onto the picture. They could be hash marks, congruent hash marks, little tick marks. They could be boxes for right angles, or they could be arrows, which we'll talk about today with parallel lines. And those are drawn on to demonstrate particular characteristics. We've talked a lot about notation, like a segment bar, array notation, a line notation. So that's when we're using symbols in place of words. And that's just so we don't have to write so much. And we'll use that in our proofs in chapter 2 also. All right, so our vocabulary, we have some that we've already seen, but we're going to look again at the markings a little bit more. So we know perpendicular lines are lines that intersect to form right angles. We talked about that yesterday. Two lines that intersect to form right angles. Now, I have the words part written out. If you don't want to write it, you're not required to. The words would be how we'll read the notation. A lot of you might just want to write the notation, but it's up to you. So the words would be line AB is perpendicular to line CD. The notation is what you're going to see, but the words are how you would read that out loud. Line AB is perpendicular to line CD. So what markings would I have to add to the picture to demonstrate those characteristics? If I tell you something is perpendicular, what marking would you add, Evelyn?
A box in one of the corners.
Good, a box in one of the four corners. If you want to put all four, you can, because one indicates that they're all there. But sometimes it gets confusing when you have too much stuff in your picture. And you'll see that later in the year. Okay. Everyone make sure you did add this to your notes. This is the box. All right, the next one is a segment bisector. We've talked about the word bisector, but we're actually going to define it here. A segment bisector is a line, a segment, or array that, remember, cuts through and makes it into two congruent segments. So it'll cut the segment into two congruent segments. I put AKA cuts it in half. It will go through the midpoint is another way to think of it too. And then we're also going to see the angle bisector that we were talking about with that one question that Michaela and Reagan were asking about. So there's different types of bisectors. The words would be line CD bisects segment AB. The notation, all you really get to do is put line and segment bars, but you still have to use the word bisects. There's no symbol for that, just the word bisects. No, it's not that long of a word. All right, now it is important to understand the segment bisector. So whatever comes first is what is doing the cutting. Like in my example of the frog, like that would be the knife. Okay. What comes after the word bisect? This is what is being cut in half. Oh. My animations are working against me as I write here. So you want to make sure that you don't mark CD as being congruent. You're saying that CD is doing the cutting, and it is cutting AB into two congruent parts. So the markings that you need are just a congruent segment on each little part. That's it. All right, now the next one is our perpendicular bisector, which takes perpendicular and segment bisector and puts it into one. But instead of saying it is perpendicular and a segment bisector, they omit the word segment. So it does two things. The perpendicular bisector is perpendicular and a segment bisector. So it is a segment or array that is perpendicular to So you guys are just filling in the part that's underlined. Perpendicular to the segment at its midpoint. Therefore, bisecting the segment into two congruent parts. Okay, the words again are kind of long. Line ST is the perpendicular bisector to segment QR. The notation, you really just get to insert a perpendicular symbol and do line and segment bars, so it still is kind of long. And you don't have to write out the words on your notes unless you think you need to. Most of you can look at the notation and read it out loud, I think, at this point, but. So when you're given a perpendicular bisector, which we're going to see these a lot for the first 4 chapters with our proofs. We're going to get into triangle congruence proofs, but this will be in your given. You need to make sure you mark 2 things. You have to mark that it's perpendicular, so the marking for perpendicular is 1 right angle or 4 right angles. You also need to mark that it is a segment bisector as well. So you have to mark that this segment is congruent to that segment. So ST again is the one that's doing the bisecting. QR is what's being bisected, being cut. So make sure that you have these 2 different markings on your picture. Okay. Angle bisector is a ray. It has to be a ray. It could sometimes be a line also, but it's usually a ray that divides an angle into 2 congruent coplanar angles. A ray that divides an angle into 2 congruent coplanar angles. So in this picture we have ray ED bisects angle GEF. So what markings would I have to add in if ED is the bisector of angle GEF? Jax?
The congruent marking on GE.
You said put congruent markings on GE and EF. At no point does it talk about a segment at all. It talks about an angle. Danielle?
We would do little half circles.
Yes. So angle, this whole angle is being cut into 2 congruent angles. So I would put a congruent mark on angle GED and a congruent mark on angle DEF. Okay, this is not necessary to be there, but this is cutting through the middle of the big angle and it's creating 2 congruent angles. So like if I knew the whole thing was 100, each of them is 50, 50 and 50. Or if I know it's 80, they're 40 and 40. And then the last thing we have is our parallel lines, which we know those are 2 coplanar lines that do not intersect. We've defined that earlier, but you've never seen the notation for it. Well, I guess you've seen the notation, never seen the markings, excuse me. The notation would just be to put the parallel symbol, which is 2 vertical little segments to indicate parallel. You probably all saw those in algebra, I would think. Yeah? The markings are the ones we haven't seen. I think I introduced them in one of the lessons, but they weren't actually in the notes. These are the little arrows. Now, it's not a whole arrow. It's just like the tip of the arrow. And you'd put matching number of them on each of the lines. So, like, if you had more than 1 pair of parallel lines, you could put 2 arrows and 2 arrows, just like the hash marks, but they're arrows. Hash marks indicate congruence. The arrows will indicate that they are parallel. No, it does not matter which way they point. So if you wanted to put them backwards, that's fine. Good question. Because rays, remember, it did matter. These doesn't matter. Okay. Finally, we're done writing. That was so boring. Okay, let's draw. Now, you're not drawing these precisely, you're sketching, but you will add in markings to tell me that something is congruent, parallel, whatever. So even if they don't look congruent or parallel. Now, some of you will think this is the easiest thing you've ever done, and some of you, again, will be like, I have no clue what I'm doing. So you want to look back at your notes tonight in your homework. Again, you're teaching yourself this vocabulary, and you're applying it to problems. So we're reading the description, drawing, and marking. So this says ray RL bisects angle ARB. So the first thing I would start drawing is I would draw angle ARB. Does it matter what it looks like? No, it just needs to be an angle. I would make it big enough that you can add something in the middle of it. Okay, so I'll start with an angle. Again, you could make it more obtuse, more acute, it doesn't matter. But we need to put points A, R, and B. Does it matter where I put them?
Just as long as the A and the B are like the outside.
Perfect. As long as R is the vertex, it doesn't matter where you put A and B. But A and B cannot be the vertex. So put R there. Most people just kind of go in order. A, R, B. Okay, we start off with our angle. Now, RL bisects. Ray RL bisects. What does that mean it's doing? Right?
It'll share R as the vertex, but goes in the middle of the
Good. So this is going to cut this angle into two congruent angles because this is an angle bisector, not a segment bisector. So I'm going to draw ray RL. Try to make it go through the middle as best you can, but it doesn't have to be perfect. To show that it's going through exactly the middle, we put congruent angle markings. That's it. Okay. The next one says line CD bisects segment QS. So again, this is what's doing the cutting. This is what's being cut. Okay, and this time it's being cut into two congruent segments, not two congruent angles. So you would want to start by drawing QS, segment QS. It doesn't matter how you draw it, just as long as it has two endpoints. One is labeled Q and one is labeled S. Okay. Now, line CD is going to cut it in half. So some of you might want to go ahead and put the midpoint in because the line's going to have to go through that midpoint. And we'll mark it that those two are congruent. Now this line can go in any direction you want. Most of you will draw it like this, right? Because I've talked about like dissecting the bronchos in the middle. That's perfectly fine. It does not have to go straight up and down. It could technically go slanted if you wanted to. Like it could go like this or it could go like that. It doesn't matter. But most of you are going to draw it up and down, so I will. Don't put a right angle though, because we don't necessarily know it is a right angle. Now we'll label this line CD, so just put a point somewhere on it, C. If you want to call this point D, you can, or you could put another point down here, CD. Doesn't matter, just as long as D's on it. And D could be at the top, and C could be at the bottom. Okay, the next one we have parallel lines. I think you guys can handle this one. Line AB is parallel to line JK. So we're going to draw two lines. Doesn't matter what direction or slant or slope that they're at, just as long as they appear to never intersect. We'll label one of them AB, one of them JK, and then we will put the marking. What's the marking again for parallel lines? Yeah? A little arrow, one on each. If you wanted, you could put 2 and 2 or 3 and 3, but usually you start off. Okay? Perpendicular. Remember, this symbol only means perpendicular. It does not mean it's a perpendicular bisector, just 90 degrees. So we draw two lines that intersect to form right angles. Doesn't matter which one you label with which. I'm going to put CF going horizontally and XB going vertically, but that again doesn't matter. And the marking would be just a right angle box. And if you'd like to put all 4 right angles, go for it, but you only need one. Okay. The last one, it says that it's a perpendicular bisector. So you just sort of remember that that's going to do two things. It's perpendicular and it's technically a segment bisector. Okay, they just don't write the word segment. So what would I start drawing? Would I draw line HD first or segment PO first? Ken? Yes, start with the segment that's being cut. And again, I always draw it straight across, but you could draw it slanted if you wanted to. Now line HD is coming down through, it's making a right angle and it's going through the midpoint. So I always draw the midpoint first and I mark it, and then I'll draw this line. It does need to be exactly a right angle this time, and we'll label that line HD. So we should have a right angle box and congruent segment markings. Just kidding. Alright, our last two then talk about the angle bisector. They're actually drawn for you, but we're going to do some algebra with them. Okay, so it says, this should be a ray. It looks like a line bar to me, but it should be right. Ray WR bisects angle AWB. Okay, so as soon as I see the word bisects, I want to add in congruent angle markings. So AWR and RWB have to be congruent. Just like when we saw the word midpoint, we put in segment markings. And then they give us information that's already in the picture, but normally you would write that in if it weren't in there. They want us to find the measure of angle AWB. So they want to find out how big the total angle is. What equation would I write to solve for x, which would then help me find the measure of angle AWB? Evelyn?
X equals 4x minus 1.
Perfect. If the angles are equal in measure, or congruent, they have to be equal as well with their algebraic expressions. And then we would just solve. Oops, -3. And we get x equals 16. Now remember, they wanted us to find also the measure of angle AWB, which is the whole angle. So I'm going to take 16 and I'm going to plug it back in. So x is 16, so that's just 16 degrees. Now this one should be 16, but double check. 4 times 16 minus 48. That will get me 16. So again, angle AWB is this whole thing, so 16 plus 16 is 32 degrees. Try the next one while I pass out your homework. We will still do the closure too, because you have to draw your own picture for that one. It's a little bit different. We'll set it up at least. There's a lot of room for your drawings. They don't have to be that big, but. Remember, if there is not a picture given, but there's a description, you always want to draw one. Okay, so for this example 3, we should have set them equal. And what did we get when we solved for x? Parker?
45.
Close. 15. We should get 2x equals 30. Subtracting 3x, adding 25, and then divide, we get 15. Now we have to find the measure of angle JKN, which is just the small one this time. So we take that 15 and we plug it back in, and we should get 75 minus 25 gets me 50. So again, to get that, all we did was plugging in. Okay. Now before we pack up, since there's still 2 minutes left, the closure question is similar to ones you'll see on your homework.
Please excuse this interruption. Mrs. Chacon, could you please call 6524? Mrs. Chacon?
The whole back of your homework is like this.
6524. Thank you.
You need to draw a picture when they don't give you one. So it says YG, ray YG, bisects angle XYZ. So I drew XYZ, which kind of looks like 90, but it's not. Then I'm going to draw ray YG going through the middle. Remember, bisects means cut into two congruent parts. So we mark it. Then we put in what they tell us. XYZ is the whole angle. So this whole thing, 5x minus 10. XYG is this little one. They're both 25, yes. If that's 25, this is 25, so you would use the angle addition postulate that 50 is equal to 5x minus 10. X does equal 12. Have a good day, guys.